So we're asked to perform the integral of this particular function, and it's with respect to x. So looking at this to try and figure out what technique to use in order to integrate, the first thing I can see is that I've got a fraction, and I've got x's on the bottom line of that fraction. So that immediately tells me that I'm probably going to need to use the rule where when I integrate 1 on x with respect to x, it goes to become log x plus c. Okay, but in order to use this rule, what we can see is that the degree of the x on the bottom line here is equal to 1. And unfortunately at the moment we have it as a degree of 2. Okay, so what we're going to need to do is partial fractions in order to make the new partial fractions which have a bottom line or a denominator with the degree of 1. Okay, so that's going to be my first step. So in order to perform partial fractions, what we need to do is make sure that the bottom line here is factorized into brackets. So let's start with that step. So x squared plus 5x plus 6. So I'm going to use the kind of multiplication and addition technique. So what that means is the first number multiplied by the back number is going to be 1 times 6. And the middle number with the x term is equal to 5. So I need to find factors of 6 that add up to give 5. So I could have 1 and 6, or I could have 2 and 3. Alright. So what I'm going to find here is that the 2 and the 3 is the one I want. That's because 2 times 3 is equal to 6, and they add together to give 5. So 2 plus 3 is 5. I'm not going to be able to use this one because although 1 times 6 is equal to 6, adding them up is not going to be equal to 5. And even if I set one of these as a negative, so the negative one here, alright, they would add to give 5 then, but multiplying them together is going to give us negative 6, which is not correct. So these are the two values that I need to split the middle term into. So I'm going to get x squared plus 2x plus 3x plus 6. Alright, so all I've done is split this into two different parts here. So now I need to factorize. So putting the first two terms together, I get x outside of x plus 2. And putting these two terms together, the common factor is 3. So it's going to become x plus 2 inside the bracket. Putting it all together, I'm going to get x plus 2, x plus 3 for my factorization. So that can replace the bottom line here. So we're going to have the integral of 4x divided by x plus 2, x plus 3. Now, before I get to actually performing the integral, we said that we need to do the partial fractions on it so that we get the bottom line, all right, to be in terms of x rather than an x squared. So let's do that as our next step. Right, part frac here. So setting it up, this is not a special case or anything. Our dummy fraction is just going to be a divided by the first bracket and b divided by the second bracket. Alright, so now we need to go through and figure out what a and b actually are. I can start that process off by finding a common denominator for these two fractions. So if I multiply this first fraction by x plus 3 over x plus 3, alright, I'm going to end up with the denominator being x plus 2 times x plus 3. And then if I do the opposite for this one, sorry, I've just copied that wrong, it's x plus 3. So if I multiply this fraction by x plus 2 on x plus 2, it's going to end up with the same denominator. So I can write this. And rather than separating it out, let's just keep it going on the top line here. And we'll carry this down. Alright, so what we can see now is that actually having a common denominator here, it's coincidentally ended up with the same denominator over here. So what I can do is say this side cancels with this side, and we drop all of that. That means that our equation becomes a lot simpler, just a top line. Alright, so now we can go through and pick convenient values for our x's in order to get a and b to drop out. So the first one I'm going to pick is x is equal to negative 3. That's because when I sub it in this bracket, negative 3 plus 3 goes to 0. So it's going to mean that 0 times a disappears from the equation and b should fall out. So we're going to get 4 times negative 3. This we just said dropped out, so I'll leave it. We're going to get b times negative 3 plus 2. So that's negative 12, and this is negative 1. So b is just going to work out to be 12 on its own. So let's go through and pick another one. This time, if we let x equal negative 2 here, it's going to drop the second term to be equal to 0. So subbing in negative 2 every time we see x. And we said this one disappears, so I won't bother writing it out. So negative 8 is equal to a times, this is going to be 1. So a goes to negative 8. Alright, so that means we can now rewrite our fraction with a and b as numbers. So this fraction here. Alright, so a was equal to negative 8, and b was equal to positive 12. Alright, so this is what we needed to integrate, right? It's just another way of rewriting it. Again, it's the same as what we had up here in terms of rewriting it. So now all we have to do is go ahead and actually integrate this equation. So let's pop it over here. Alright, so integrating this, negative 8, that's just the constant. So that stays out the front. And then this bit here is going to end up in the natural log. So natural log of x plus 2. Same process here, 12, that's just the constant that stays out the front. And applying this rule, this one ends up going inside the log, x plus 3. And because this is an indefinite integral, we need to end up with the plus c on the end. And I just want to quickly show you that you can integrate this using the substitution rule if you're unsure of how to jump to this step directly. So let me just quickly demo that. Alright, so if we're using integration by substitution, we introduce a new variable, which I'm going to call u, and we make it equal to the complicated part of our equation. So in this case, the highest degree bit is the x plus 2. When we take the derivative with respect to x, the derivative here is just going to go to 1. And that means that we're going to get du is equal to dx. So if we go and substitute this stuff back up into our equation, we're going to get the integral of negative 8. This we can sub out with u, and dx gets substituted out to u. And now all we've really got is directly the rule. If you want, you can even take the negative out the front. So we've got the integral of 1 on u with respect to u. And that's the same as this rule we talked about up here, just in terms of u rather than x. So when you do it, it becomes negative 8 times the natural log of u, and we get the plus c from it being indefinite. And we can replace, if we want, the u here with, we said it was equal to x plus 2. Alright, and hopefully what you can see is this bit here, the negative 8 natural log x plus 2, is the same as what we got up here, just doing it kind of directly. Up to you which method you choose, but yeah, you can always double check it using the long version of the chain rule, of the substitution rule if you're keen. You could apply the same method to this one here to prove that it's equal to that as well. So that's all there is for this video, and I'll see you in another one.